Coming to your the company, right? Take me to space. Who are your clients? Who do you provide services to, or who are your potential clients? I know you teamed up with ISRO, but ultimately the clients are going to fuel your
Mhm.
company, right? So who would they be?
So just to clarify, ISRO is my launch partner. Right?
Okay.
So we, of course, as an Indian company, we get access to the ISRO rockets to launch to orbit. No, okay. Coming to the company that's taken to space, if you look at our aim is to build large-scale compute infra in orbit, compute and storage infrastructure in orbit, right? Which you call it a data center in orbit. Now, the value prop is end of the day compute and storage. I'll do compute for you and storage for you. For any customer who is today availing a terrestrial compute and storage, terrestrial data center, for them to move to space, either it has to be cost effective or a value prop that terrestrial is not able to serve, right? Just because the space is cool, nobody's going to pay me money for that, right?
True.
Today, the unit economics behind data center space does not allow me to go behind terrestrial use cases. For example, if you ask me, hey, are the AI training companies paying you? No. Are the database companies paying you? No. The sector today that Take Me to Space goes after is a space data set itself. Because that's why there is space data and there is terrestrial data, right? Terrestrial data, you are aware of. Space data, if you look at, is all the data that is generated by the satellites. Let's say Earth observation data, LiDAR data, debris data. They are today downlinked to Earth, and then the analytics is done on top of it, right? What we have figured a niche is, hey, because I have this computing info available, I can do the computing in orbit itself and only download the results. Now, what it gives value to the customer, it overall reduces the cost of accessing the ROI by a factor of 5 to 8, right? Now, imagine you are a chips company, a large scale chips company, and you have 5,000 hectares of potato farms. जो आपका बिजनेस एनालिस्ट है, वो डेली का पोटेटो फार्म का एक पिक्चर नहीं देखता, उसको देखने की मेरा हेल्थ ऑफ द फार्म कैसा है, राइट? Only when you find an anomaly, अरे 1,000 hectares have suddenly gone bad. That's when you want to look at the picture. But today, why should you pay for the data? Which in your today's cost, the downloading of data from satellite is also integrated, right? Because you download the data and then do the analytics. What we are telling those chip maker is, hey, you upload the same AI model to a satellite. When the satellite passes over your area of interest, your application wakes up, captures the data, does the compute, and gives the result. If you find an anomaly, go and buy the data from another Earth observation satellite.
Okay.
Right? So that's how we have figured a niche in the compute industry and giving value to the GIS customer, the geographical information system, right? The customer who are today buying the the commercial sector, the commercial enterprises that are today buying Earth observation data, we are telling them, hey, you don't have to buy EO data daily. You can upload the same inferencing model to orbit and download on the inferences. And that's the sector we're going after. So that is where the money is today.
Okay.
We call the user, because end of the day, we are building the infra, and the user is accessing our compute via a web application called Orbit Lab.
Okay.
Right? And the reason we call it lab, again, when you and me started school, there was no concept of data center. We had a computer lab in our schools, right? Because it's a 20 कंप्यूटर लगा था, 20 कंप्यूटर का डेटा सेंटर नहीं बोल सकते, लैब बोलते उसको. Hence today I call ourselves Orbit Lab, because I have 200 watts in orbit. The moment I have 1 gigawatt, that's when I'll call myself orbital data center.
अच्छा.
ऐसा मार्केटिंग के लिए बोल के फायदा नहीं है ना. So today our position is very clear with Orbit Lab. Upload your AI models, run your experiments, or run your orbital inferences in orbit. That's where the money is today. What we see this market positioning, like we have raised $5 million to get to, from 200 watts, I want to jump to 5 kilowatts. What the hypothesis is, I think by 2030 or 2033, with the likes of Starship or the New Glenn rocket coming in, or India mein startup Etherealex is building a massive rocket. With this large scale rockets going up every month, your launch cost is going to grow down drastically. Today, the launch cost is at $7,000 per kg with SpaceX. With any other provider across the world, it's $10,000 to $20,000 per kg, which is obnoxiously high. We are expecting this cost to go down to like less than $500 per kg.
Okay. So you will be able to get in more clients.
No,
Is what you're saying?
build the asset in orbit at a much lesser cost.
Build the asset. Okay.
Because see, as a business, if I'm building an asset, I have to recover the cost, right? I'm not doing an NGO, right? I have to make profits as well. So any satellite-based infra that you build in out of 5 years of life in LEO, you have to recover your manufacturing cost of your satellite, the launch cost of your satellite, and the replacement cost of the satellite, because satellite is like potatoes. आपने potato एक बार, once you have farmed your potatoes, they have a shelf life, right? उसके बाद you have to replace the potato with new potatoes. Satellite also exactly like that. वो उसको replace करना पड़ता है. So yeah, all the three costs have to be recovered, so that after that the margins kick in.
Okay.
If my launch cost is very high, that means customers to bear the cost. Right? So that's why I said the unit economics don't allow today.
Okay. So what kind of clients did you mention?
The GIS people who are today buying Earth observation data, agriculture.
Agriculture.
So
okay.
Just to make it more specific, large AOI, we call it area of interest. Okay. Large area of interest customers who are buying satellite imagery for very large areas of data. There's 5,000 hectares of farms. If you are doing disaster management and you're looking at a much, or oil
Disaster
spillage.
management. Oil spillage.
Okay. So there's a large area of interest. Then there is time sensitive customers.
Okay.
Right? Now time sensitive customer like a insurance company. If you're an insurance company, if there's a disaster somewhere, you want to be the first one to assess the disaster and provide the premium first, or the claims first.
Okay.
So that your brand value goes up and hence people come to you for
Got it. Okay.
Insurance, this thing. Premium.
So you have agriculture.
Agriculture is the biggest sector, which is the large AOI sector.
Got it.
Then the time sensitive sectors are supply chain. You want to monitor logistics.
Logistics. Okay.
Or minerals and oils. And
but that Google also does, right?
Now,
the logistics part?
No, it does. Okay, I'll give you an example. Defense example I'll give you.
Okay.
India-Pakistan border, 2,000 kilometers. When you do, let's say, SAR imagery, right? It is 300 gigabytes of data.
Okay.
To download 300 gigabytes of, let's say this is the India-Pakistan border, right? The satellite moves from here to there. It captured 300 gigabytes data, and that's where the ground station is. Immediately, let's say, वहाँ ground station भी है. आपने 300 gigabytes data download करना शुरू किया at a 1 Gbps speed.
Okay.
That means from here to all the data getting downloaded, it takes 30 minutes. But guess what? From the truth being captured for the truth to start the analysis, there was a 30 minutes delta.
Okay.
Right?
So the time is of essence.
Time is of essence. But if you could, while capturing the data, and this is where you did because inferencing takes few seconds. If you could find the results will be few megabytes. So you'll get it in a second. Right? So suddenly you save 30 minutes of time from a defense intelligence point of view. Right? Now, coming back to the commercial use case, even if you save 2 hours of time for a hedge fund to know what is a congestion in Panama Canal.
Got it.
Right? So that time becomes, so hence time sensitive customers.
So which means any event which has, ramifications or implications
on time. Yes. By not downloading large data set, I'm trying to save time.
Got it.
My hack is simple. I will not download the data.
So this thing processes in the satellite and will
download the inferences.
Okay.
Because inference, like if you look at the health of the potato farm versus the potato farm imagery.
Got it.
Like Excel sheet versus image database, right?
Okay.
It's a big difference.
Okay. So there are images and there is computing thing also into it, right?
Yes.
Predominantly that is what you're operating at.
Yes, I'm operating at the enabling compute for the space data, for the
space
data.
Okay,
Yeah.
okay.
That's the business today.
Okay.
And as the unit economics of the market matures, then I will start going after the terrestrial data set.
Terrestrial is?
Like AI training workloads, right?
AI training.
Today, if you look at to train a GPT, it takes anywhere between 3 to 6 months, right? Today, we are at what? 50, depending on the company, we are at somewhere between 50 to 70 billion parameter network, right? Now, to train a billion parameter network, you need few gigawatt worth of energy.
Okay.
Because that much data centers should provide, right? And that is the edge OpenAI versus Grok versus your Anthropic have, right? Musk has 200,000 GPUs ka farm, right? So there is a certain amount of energy that he has. We can train the GPT models. Now, suddenly think about a world where we're talking about, let's say, from 50 billion to 1 trillion parameters. The models are going to become more complex with time, right? Of course, they'll become efficient, but they'll also become larger. You would suddenly need 10 gigawatts of energy, right? Now, on terrestrially speaking, to build a 10 gigawatt data center, आपको land खरीदो, electricity, it's a nuclear power plant बनाओ, ठीक है, electricity grid से नहीं लोगा. You have to buy a nuclear power plant or those gas turbines, the hot geyser thing that is going on, or some kind of energy setup you have to do. Then you have to set up the data. It's a 2-3 year project. But in space, if you have the building blocks, you can launch 4 or 6 rockets and you have a 10 gigawatt data center ready. And that will give those compute companies an edge. I can scale things faster. किसी से permission लेना, किसी को bill नहीं देना.
This is what NVIDIA is trying to do.
With anybody going after ODC is trying to do.
Okay.
Anybody behind the ODC dream is going after not because
ODC
of cost.
dream is?
Orbital, sorry.
Okay.
Orbital data center.
Okay.
We just call it ODCs.
ODC, okay.
ODC, orbital data center. So anybody, there are globally, there's SpaceX, there's Google, there is Nvidia with there's StarCloud, there's Sophia Space, there is Ether Space now.
Okay.
In India, of course, there's Take Me to Space. In Israel, there's Raman Space. There are a lot of these companies trying to aim to build orbital data centers primarily, and the driving factor is not cost. Of course, cost is involved. To reduce cost, we want to make it as cheaper as possible, but the human needs of computing power, or the energy required for the human need of computing, cannot be served terrestrially at all.
Okay.
It has to be in an environment where you don't have a problem of scale, right? 10 आपने मान लो 10 बार solve भी कर लिया, 100 gigawatts के लिए कुछ चाहिए होता, किधर से लेके आओगे? You can't solve that problem on Earth. You have to hence start somewhere at space. The question is whether they start at 1 gigawatt or 10 gigawatts or 100 gigawatts. It is going to happen.
Okay.
When is the question? At what point do we say that, okay, enough, we can't afford more? This training data centers coming up in. By the way, Bernie Sanders just put a moratorium. He passed, I think he put for a bill yesterday or day first, Bernie Sanders, that no more AI data centers. They're increasing the electricity cost of the cities. Because if you have a data center in the city, the amount of power they consume, the average consumer has to bear the cost of it. Right? वो इतना power hungry होता, right?
So the data centers, if it's put on space, right? So where does the energy come from?
Sun, free.
Sun. Okay.
It's absolutely free. Free of course देता बंदा.
And it
and
keeps
30% more.
30% more energy.
Energy
Okay.
there.
And the maintenance cost and.
By the virtue of the name, there's no maintenance. You can't do maintenance. कैसे करोगे? मतलब बहुत चला गया ना ऊपर.
Then robotics, you have your.
The cost is so high. So you, in space, we design an asset in a way that it's a capex business and zero opex business.
Okay.
If you're designing for opex, you're fundamentally doing wrong engineering.
Okay.
You design a way that अगर खराब होता है, replace that guy.
Okay.
I will not maintain the guy.
Okay. Okay. Oh, got
Yeah.
it.
So replacement is cheaper
Use
than
and throw.
Use and throw. Replacement is cheaper than maintenance in space today.
Okay.
It might change over time, but we will see.